Hi there, and welcome to this lesson on Pure Mathematics 4. In this lesson, we're on Chapter 6, 6.1, and how you integrate functions which have been given parametrically. Now, the chain rule appears in many forms in calculus, and it is behind the method that we use for integrating parametric functions. If y is written parametrically, so x and y both written as functions of t, x is f of t, y equals g of t, then if we want to integrate that parametrically, it's equal to the integral of g of t times by the differential of f of t, f dashed of t, and integrating that with respect to t. Now, the order of these two functions does matter, so take care. G of t is the function for y, and f of t is the function for x. Okay, let's have a look at an example. The function given in Cartesian form, y equals 3x squared, can be represented parametrically by the equations x equals 2t and y equals 12t squared. And we're asked to find the area under that curve from x equals 6 to x equals 10 by both methods. So first of all, just by doing a normal integration using y equals 3x squared, integrating that and then putting in the limits x equals 6 and x equals 10, and then we'll do the same question again, but this time integrating it using the parametric equations and putting in the limits t equals 3 and t equals 5. And that's important to notice. When you're integrating with respect to x, the limits have to be given in terms of x. When you're integrating with respect to t, the limits have to be given in terms of t. Now, in this question, the limits have been given to you, but you might have to work them out yourself. If you had to work them out, you'd use the relationship between x and t. So we're told that x is equal to double t, 2 times t, which means t is equal to a half of x. So when x is 10, t is a half of that, which is 5. When x is 6, t is a half of that, which is 3. Okay, have a go at doing this question by both methods. You should get the same answer both times. Pause the video, have a go, and come back to me when you're ready. Okay, let's have a look. So first of all, just doing a normal integration, y equals 3x squared, so it's the integral of 3x squared with respect to x. Integrating that gives us x cubed, the limits are 10 and 6. Putting in 10, we get 1,000. Putting in 6, we get 216. That gives us 784 for the answer. Now, doing the same question again, but this time integrating parametrically. So g of t, that's the function for y, which is 12t squared. F dashed of t, that's the differential of the function for x. So it's the differential of 2t with respect to t. So g of t is 12t squared. The differential of f of t will be 2. Multiplying those together gives us 24t squared. Integrating that with respect to t gives us 8t cubed. And then putting in t equals 5 and t equals 3 gives us 1,216, which gives us 784 again. So same answer as before. Okay, example 2 is slightly harder because the integration that you're going to have to do is slightly more tricky. We're asked to find the area under the curve represented by the parametric equations, x equals sine t and y equals 2 cos t, between t equals 0 and t equals pi by 3, using the normal formula with the normal definitions for x and y in terms of f of t and g of t. When you do the integration, you're going to have to use a trig identity that turns up on a lot of integration questions. But anyway, have a go at the whole question yourself, pause the video, and come back to me when you're ready. Okay, let's have a look. So g of t in this question is 2 cos t. F dash t is the differential of sine t, which is cos t. That means we've got the integral of 2 cos squared t dt. Frequently, we have to integrate cos squared or sine squared. The method's always the same. We use the double angle formulae for cos t. So cos squared t is equal to a half into cos 2t plus 1. Tidying that up gives us cos 2t plus 1. Now we can do the integration. That gives us a half sine 2t plus t. Now we can put in the 2 limits. Putting in pi by 3, we get root 3 over 4 plus pi over 3. Putting in 0, we get 0. And that does simplify to just root 3 over 4 plus pi over 3. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 68 and have a go at exercise 6A. Thank you very much for listening, and cheerio.